As the San Andreas Fault line continues to shift and crack, experts are sounding the alarm about an impending disaster that could unleash record-level flooding. Could this be the catastrophic event Californians have been fearing for years? Join us as we explore the ominous signs and ominous predictions surrounding the San Andreas Fault and what it means for the future of the West Coast. The most well-known fault in the world is the San Andreas Fault. It is well known partly because of the terrible 1906 San Francisco earthquake, but mostly because it goes through California, a state with a lot of people who are often in the news. And because so many research institutions are studying it, the SAF has become a well-known name. But what's a mistake? Who is the SAF? A fault is a crack in the surface of a rock along which the rock has moved. Most mistakes are small, even microscopic, and don't matter much. Some faults go on for many miles. Rocks on either side of a fault move in one of three directions in space, which can be used to group faults. They are called dip-slip faults when the movement is mostly vertical. Thrust faults are dip-slip faults with dips of less than 45 degrees. The fault is called a strike-slip or transform fault if most of the movement is horizontal and parallel to the fault plane. The SAF is a transform fault on the right side. This means that if two people are standing across the fault from each other and the fault moves, they will both see the other person move to the right. If the rocks move horizontally away from each other or toward each other, this is called divergent or convergent movement. Convergent faults raise pressure ridges and mountain ranges. Gaps or sags are caused by different problems. There is always a subduction zone where the edges of two plates meet. When they go in different directions, they often create valleys on land and ridges in the ocean, like the Mid-Atlantic Range. At plate boundaries, the fault plane is seldom vertical, i.e., a dip of 90 degrees. In fact, the SAF's fault plane is almost never straight. The San Andreas Fault is where the North American Plate and the Pacific Plate touch. The plates are rigid, or almost rigid, slabs of rock that comprise the crust and upper mantle of the Earth. As the crow flies, the SAF is about 700 miles long, and when its curves are taken into account, it is about 800 miles long. It goes from the Salton Sea in Imperial County to Cape Mendocino in Humboldt County and is about 10 miles deep. The plates are always moving, but where they touch, they stop moving. As the rest of the plate moves, the parts that are stuck change shape, like a spring being compressed. This makes the rocks along the fault more stressed. When a piece of rock breaks or slides, the plates move quickly, which causes an earthquake. The whole thing is known as elastic rebound. As they break and scrape against each other, they send out seismic waves that travel through the ground and shake the surface. We know this shaking as an earthquake. While we think of plates as rigid, they can stretch a little like pizza crust. This is why the SAF in Northern California can have an earthquake, but the SAF in Southern California can't. There are many major faults in California that are parallel to the SAF, like the Hayward Fault. This has a strange effect. While the Pacific Plate moves northwest relative to the North American Plate at an average rate of about 2.5 inches per year, about as fast as your fingernails grow, the average slip rate along the SAF is less, at about 1.5 inches per year. Slip along the other parallel faults is making up for the difference. This can be demonstrated by a deck of cards. People often think of the SAF as a line in the ground, and that they can get from one plate to the other by hopping across it. This isn't the case. Although the most recent break in the ground that defines the trace of the SAF is a narrow line, the actual plate boundary should be viewed as a fault zone. The width of a fault zone can be less than a mile wide, Olema Trough, or many miles across. Salton Trough, California is known for its earthquakes on the San Andreas Fault, such as the 1906 San Francisco earthquake and the 1857 Fort Tejon earthquake. However, the earthquakes in California are not very big. The world's biggest earthquakes happen near subduction zones, where one tectonic plate slides under another: Alaska, Chile, Indonesia, etc. Only in northwestern California zone of Cape Mendocino is there a subduction zone, the Cascadia megathrust, and it is not directly related to the SAF. Here, the small Juan de Fuca plate is subducting under the North American Plate. If you give the Cascadia megathrust enough time, it will cause an earthquake that is much bigger than any on the SAF. It's been done before. About 28 million years ago, the SAF was formed. It began when the East Pacific Rise, the boundary between the Farallon and Pacific plates, went under the North American plate near where Los Angeles is now. Spreading northwest and southeast, the SAF gradually grew, and it's still growing. California is slowly changing shape because of the moving plates and earthquakes. California will look very different in a few million years than it does now. Take this into account. California is about 1,000 miles long. The crack is about to open. The San Andreas Fault is on the verge of crumbling. Thomas Jordan, the director of the Southern California Earthquake Center, recently made an announcement that should have sent a shiver down the spine of every Californian. He stated that the San Andreas Fault appears to be in a critical state, and as a result could generate a large earthquake in the very near future. The warning that the southern portion of the fault looks like it's locked, loaded, and ready to go is something that is brand new. Of course, the reiteration of the seismic peril to Californians will not come as a surprise to anyone, but what is brand new is the warning. What might possibly be the motivation behind this renowned seismologist's scary statements? Since 1857, the southern sector of the San Andreas Fault system has not experienced a significant release of stresses due to the fact that there has not been a large earthquake there. 1857. The San Andreas Fault is just one of several fault systems that approximately characterize the boundary between the North American and Pacific tectonic plates. To put it another way, the San Andreas is a mountain range. Both plates are moving in what may be described as a roughly northerly direction. However, the Pacific plate is moving at a rate that is considerably higher than that of its North American counterpart. This means that strains are continually building up between the two plates. Some of these tensions were released catastrophically in the San Francisco Bay Area in 1906 during an event of 7.8 magnitudes, and then again in Northern California with the 6.9 magnitude Loma Prieta earthquake in 1989. Both of these events occurred in California. Events of these magnitudes, however, have not occurred along the San Andreas Fault in the southern part of the state. The 1994 Northridge event was associated with a nearby but separate fault system, leading to the suggestion that one is imminent. And, given the amount of stress that might actually have accumulated, when it arrives, it will be the big one. Events of these magnitudes, however, have not occurred along the San Andreas Fault in the northern part of the state. How big is big? How severe may this prospective earthquake be? And is it even remotely plausible that the devastation depicted in the movie San Andreas could actually take place? In a nutshell, residents of California are going to be, to a certain extent, satisfied with the responses to these questions. In the movie, the San Andreas Fault is responsible for an earthquake that registers a magnitude of 9.0. In general, earthquakes of this magnitude are confined to parts of the globe where subduction is taking place, which is when one tectonic plate is being forced below another. For example, Chile and Japan are both examples of regions on the planet where subduction is taking place. The tectonic activity in California is distinct from that in other states. At this point, two plates are moving past each other in a sliding motion. As a result, the most recent predictions put the maximum possible earthquake magnitude along the San Andreas Fault system at 8.0, despite the fact that there is only a 7% probability estimate that such an event could occur in Southern California in the next 30 years. However, there is a 75% chance of an event with a magnitude of 7.0 occurring during the same time period. Although the differences between magnitudes 7, 8, and 9 may appear to be negligible, there is a significant difference in the amount of energy that would be released by such events. An event with a magnitude 9.0 would release 32 times more energy than an event with a magnitude 8.0, and a magnitude 9.0 would release 1,000 times more energy than a magnitude 7.0. Damage is certain to occur regardless of the magnitude of the earthquake, whether it measures 7 or 8, but the entire chain of events that is presented in the movie is highly improbable. For instance, the San Andreas Fault does not run beneath any body of water. As a consequence, any movement along it cannot displace water to the degree that would cause a tsunami to be generated, having a premonition of destruction. The United States Geological Survey modeled a 7.8 magnitude event with slippage of 2 to 7 meters to represent the stresses that have built up in the area since the last large event, in an effort to gain a better understanding of the effects that would be caused by a large earthquake in the southern part of the San Andreas Fault. It was determined, using this model, that the constructions that straddled the fault would sustain the greatest amount of damage. After the passing of the Alquist-Priolo Earthquake Fault Zoning Act in 1972, thankfully, projects of this kind have become exceedingly uncommon. The 966 roads, 90 fiber optic cables, 39 gas pipes, and 141 power lines that span the fault zone are the ones that stand to be impacted by this movement. It was predicted that the overall cost of damage to structures was $33 billion, with contemporary buildings faring well, but older buildings being especially susceptible to damage. Modern buildings fared well. Once gas mains and water mains become severed, fires will break out, as they did after the Northridge earthquake. In fact, the damage that will result from the fires is predicted to be more costly than the damage that would result from the initial shaking. It is expected that 1,800 people have died as a result of the disaster. And just when it seems like things can't possibly get much worse, the major event will have destabilized the tectonics of the region to such an extent that a series of aftershocks that have the potential to be quite powerful will begin. As an illustration, Christchurch, New Zealand was hit by an earthquake of 6.2 magnitudes in 2011, and ever since then, the city and the region surrounding it have been subjected to more than 10,000 aftershocks. The good news is that the movie San Andreas is completely made up, and it features the same amount of exaggeration that we are all accustomed to seeing from filmmakers who, strangely, also have their headquarters in Southern California. Despite this, there is an extremely high possibility that the San Andreas Fault will produce a large earthquake in the not-too-distant future. When it does arrive, it will do significant devastation, and Southern California will be heavily impacted by its effects. But people who live in California are used to dealing with natural disasters of this nature, and in more recent years, the state's physical structures have been built with the protection against earthquakes in mind. You can forget about tsunamis and deep chasms springing up, but you should prepare for strong shaking, damage to buildings, fires, and significant economic consequences as a result of the region being rendered inoperable for an undetermined amount of time. Flooding of the Colorado River is linked by scientists to earthquakes in the San Andreas Fault. Dams constructed on the Colorado River after the Salton Sea was formed are thought by some researchers to be a possible contributor to the fact that Southern California is overdue for a significant earthquake. Floodwaters that periodically flowed through faults help trigger earthquakes in the area, including several large ones along the mighty San Andreas, according to the findings of a new study that was led by the Scripps Institution of Oceanography. The research was conducted by scientists from all around the world. The contemporary Salton Sea was formed about a century ago when record flooding from the Colorado River overcame barriers and, over the course of 2 years, built an enormous body of water in a desert sink. This process took place in the Salton Sink. In the end, dams and other irrigation barriers were constructed in order to halt the flow of water into the sea and put an end to the recurrent flooding that had afflicted the region for a considerable amount of time. However, geologists are unsure whether or not the formation of the Salton Sea had an effect on the seismic dynamics of the region, which is traversed by a large number of fault lines that all lead to the San Andreas Fault. Daniel Brothers, a marine geophysicist working for the United States Geological Survey and the primary author of the study, stated that in the past, the weight of the flowing floodwaters distorted the Earth's crust, causing some areas of the fault to bow and others to bulge. In addition to this, floodwater seeped into cracks and crevices in the rock, which caused outward pressure to be exerted on the faults. According to him, all of this contributed to the quakes that occurred. An intriguing notion has been proposed as an answer to a topic that seismologists have been asking for decades. Why has the southern end of the San Andreas Fault gone for so long without a large earthquake? The research offers an explanation for this question. In a seminal study that was published last year by UC Irvine and Arizona State University, researchers showed that earthquakes along the San Andreas Fault have happened much more frequently than was previously assumed, anywhere from once every 45 to 144 years on average. The region of the fault saw its most recent big earthquake in 1857. The scientists from Scripps utilized sound waves to investigate the silt on the lake bed, which included records of previous flooding going back thousands of years. Scientists found that the smaller faults that feed into the San Andreas had ruptured because of the historic flooding that occurred. On a few occasions, This resulted in a significantly greater earthquake on the southern portion of the San Andreas Fault. Records of sediment deposition provide solid evidence that a massive earthquake on the San Andreas Fault occurred in the 10th century after floods caused ruptures on the faults in the surrounding area. According to brothers, this may have also been the case with a significant earthquake that occurred in the San Andreas Fault between the late 13th and mid-14th centuries. According to what he has indicated, there are prior earthquake episodes that may potentially have been caused by significant flooding. However, the data are incomplete. The Colorado River was responsible for the rapid expansion and contraction of the old Lake Cahuilla, which left behind the much smaller and shallow remnant known as the Salton Sea. The extreme floods were finally put to an end in the early 20th century as a result of a range of projects including water control. According to brothers, there are a number of variables that might modify the state of stress on the faults, and flooding is one of them. Joanne Stock, a professor of geology and geophysics at Caltech, who was not involved in the study, stated that this would be far from the first occasion in which man-made activities have influenced seismic activities. It has been shown that the construction of reservoirs and their subsequent filling have caused primarily minor earthquakes. Following the occurrence of over 800 shallow earthquakes in the region earlier this year, 2 gas companies operating in the central Arkansas region reached an agreement to temporarily halt the process of injecting water into underground wells. About that time, approximately 8 years ago, Clear Lake, which is located in northern California, experienced an upsurge in the number of minor earthquakes, which some locals say was caused by a company generating electric power from steam heated by lava located beneath the area. The San Andreas Fault is widely regarded as one of the most hazardous geological features in Southern California. This is due in part to the fact that it is so extensive that the fault's southern section is capable of triggering an earthquake of magnitude 8.1. On the other hand, the Northridge earthquake in 1994, which occurred on a different fault, was only a magnitude of 6.7 and caused significant damage. The earthquake that occurred in 1857 and had an estimated magnitude of 7.9 is commonly referred to as the Fort Tejon quake. However, this may be a bit of a misnomer due to the fact that it is believed to have originated further north, all the way up near Parkfield in Monterey County. After then, the earthquake moved south along the San Andreas Fault for almost 200 miles, passing through Fort Tejon near the northern boundary of what is now Los Angeles County, and then moving east toward the Cajon Pass in San Bernardino County, close to where the 15 freeway is currently located. The earthquake was so strong that the ground liquefied, which led to the collapse of trees even in Stockton, which was located quite a distance away. West of Fort Tejon, furthermore, some trees were uprooted. The experts emphasize that there is not enough information known about the workings of the San Andreas Fault to definitively explain what causes its active and quiet periods. According to Susan Huff, a seismologist working for the United States Geological Survey, the idea that massive amounts of floodwater coming in and going out may alter seismic activity seems logical. However, she stated that it is difficult to determine whether the absence of floods is postponing the next big one on the San Andreas Fault. She stated that the only thing that is certain is that a significant earthquake will occur along that portion of the fault at some point in the future. Thanks for joining us as we delved into the unsettling truth about the San Andreas Fault. We hope this video has raised awareness about the potential danger and preparedness needed for such an event. Be sure to subscribe to our channel for more informative content. Click the like button if you've liked this video, and click the bell icon to be notified whenever we upload new videos to this channel. Thank you for watching, and stay safe out there. Have a great day.